Assalamualaikum. My name is Amizwan bin Sarifuddin. I'm going to repeat principle of HVAC. HVAC standard, they are related to chapter 11, air conditioning system concept. Standard related to chapter 11 are standard 62.1 and standard 15. For standard 62 is ventilation for acceptable air quality. For standard 15, safety standard for refrigeration system. So purpose for standard 62.1 to specify minimum ventilation rates and other measures intended to provide indoor air quality that is acceptable to human occupants and that minimize adverse health effects. To be used to guide the improvement of indoor air quality in existing buildings. This standard is extended to be used to guide the improvement of indoor air quality in existing buildings. For the scope, this standard applies to all space intended for human occupancy except those within single-family houses, multi-family structures of 3 stories or fewer above grade, vehicle and aircraft. This standard defines requirements for ventilation and air cleaning system design, installation, commissioning and operation and maintenance. Ventilation requirements of this standard are based on chemical, physical, biological contaminants that can affect air quality. Acceptable indoor air quality may not be achieved in all buildings without requirement of this standard for one or more. So as we can see, this is based on figure 1, this is ventilation system. I'm going to define every single term in this diagram. So for makeup air, is any combination of outdoor and transfer air intended to replace exhaust air and exfiltration. Air cleaner, device to reduce concentration of airborne contaminants such as microorganisms, dust, and extras. Exhaust air, air removed from a space and discharged to outside building by means of mechanical or natural ventilation system. For energy recovery, a device or combination of devices applied to provide the outdoor air for ventilation in which energy is transferred between the intake and exhaust airstream. Aircon unit, the process of treating air to meet the requirement of a conditioned space by controlling its temperature, humidity, cleanliness, and distribution. For supply air, air delivered by mechanical or natural ventilation to a space and composed of any combination of outdoor air, recirculated air, or transfer air. Infiltration is uncontrolled inward air leakage to conditioned space through unintentional opening in ceilings, floors, and walls from unconditioned space or the outdoor caused by the same pressure difference that induce exfiltration. Exfiltration is uncontrolled outward air leakage from the conditioned space through unintentional opening in ceiling, floor, walls to conditioned space or the outdoor caused by pressure difference across this opening due to wind, inside-outside temperature difference, and imbalance between outdoor and exhaust airflow rates. For occupied space and enclosed space intended for human activity. For the retained air, air is removed from a space to be recirculated or exhausted. So I will focus on chapter 6, section 6.3, which is indoor air quality procedure. Generally, this performance-based design procedure presented in section 6.3, in which the building outdoor air intake rates and other system design parameters are based on an analysis of contaminant sources, contaminant concentration limit, and level of perceived indoor air acceptability shall be permitted to be used for any zone or system. Breathing zone outdoor airflow and system outdoor air intake flow shall be determined in accordance with this following. For contaminant sources, for each contaminant or mixture of concern, indoor sources, occupant and material, and outdoor sources shall be identified, and the emission rate for each contaminant of concern from each source shall be determined. Contaminant concentration, a concentration limit and its corresponding exposure period and appropriate reference to authority shall be specified. Perceived indoor air quality. The design level of indoor air acceptability shall be specified in terms of building occupants. Design approach. Zone and system outdoor air flow rate shall be the larger of those determined in accordance with mass balance analysis and similar zone. So next is standard 15, safety standard for refrigeration systems. So the purpose is this standard specifies safe design, construction, installation, and operation of refrigeration system. For the scope, this standard establishes safeguard for life, limb, health, and property and prescribed safety requirements. This standard applies to the design, construction, test, installation, operation, and inspection of mechanical and absorption refrigeration system, including heat pump system used in stationary application. B. To modification including replacement of parts of component if they are not identical in function and capacity. C. To substitution of refrigerant having a different designation. For this standard, I focus on chapter 8, installation restriction, which is related to my previous chapter 11. For the section 8.3, safe access. A clear and unobstructed approach and space should be provided for inspection, service, and emergency shutdown of condensing unit, compressor unit, condenser, stop valve, and other services component of refrigeration machinery. Section 8.4, water connection. Water supply and discharge connection shall be made in accordance with the requirement of the authority having jurisdiction. Section 8.5, electrical safety. Electric equipment and wiring shall be installed in accordance with the National Electrical Code and the requirement of the authority having jurisdiction. Section 8.6, gas fuel equipment. Gas fuel device and any equipment used with refrigerating systems shall be installed in accordance with approved safety standards. Section 8.7, air duct installation. Air duct system of air conditioning equipment for human comfort using mechanism refrigeration should be installed in accordance with approved safety standard from authority. Section 8.10, location of refrigerant piping. Refrigerant piping crossing an open space that afford passageway in any building shall not be less than 7.25 feet or 2.2 meter above the floor. Refrigerant piping shall not be placed in any elevator, dumbwaiter, enclosing public stairway, stair landing or means of egress. Next is refrigerant piping shall not penetrate floor, ceiling or roof except penetration connecting the basement and the first floor, penetration connecting the top floor and machinery penthouse or roof installation. Third, penetration connecting adjacent floors served by the refrigeration system. So, refrigerant piping shall be properly isolated and support to prevent any leakage, vibration, stretch or corrosion. Next is 8.11, refrigerating machinery room. Generally, when a refrigeration system is located indoor and machinery room is required by section 7.4, the machinery room shall be in accordance with the following provision. A machinery room shall be so dimensioned that parts are accessible with space for service, maintenance, and operation. There shall be clear headroom of not less than 7.25 feet 2.2 meter below equipment situated over passageway. Each refrigeration machinery room shall contain a detector located in area where refrigeration from a leak will concentrate that actuate an alarm and mechanical ventilation. So machinery room shall be vented to the outdoor, utilizing mechanical ventilation by one or more power-driven fans capable of exhausting air from machinery room at least in the amount given in the formula. So the mechanical ventilation required to exhaust an accumulation of refrigerant due to leaks or rupture of the system shall be capable of removing air from the machinery room is not less than the following quantity. So this is the formula. Q is equal to 100 times G exponent 0.5. So where Q is the airflow, G is the mass of refrigerant in the larger system, any part of which is located in the mesh room. That's all for me. Thank you.